All right. Lovely. All right, wonderful. So again, let me just start over by making a special welcome to everybody online today. All right. I'm very, very happy to see all of you. Right. I'm happy that you guys are sucking it up with me until you know when. You know that penultimate day is coming. And I promised you at the beginning that I will be working with you right up until a few days before the exam. So rest assured that we will be working assiduously and cohesively towards the goal. We already know everybody in here has one goal and one objective, and that is to get this subject with the best pass that you possibly can get. Even if it's a 3, I'm not a big fan of a grade 3, but it is what it is. You know, once you get a pass, then you can move on with your lives to do different things. All right. So, last week you guys we would have gone through the May 2023, right? And so this year I've chosen to go through the 2024. I'm not particularly doing them in any order, but I'm trying to keep the questions that we're doing recent. So anywhere between 2021 and 2026. Now I've gotten access to the 2026 January exam that just gone. So I'm contemplating whether or not I should do that later down into the marathons or should I leave it for the last day? Because I'll be working with you guys up until the 10th. And the exam is the 12th. So the exam is the Tuesday. So I'll be working with you up until the Sunday before the exam Tuesday morning. So still contemplating whether or not I should work the 2026 later down or earlier up. I don't know. But I'm going to run a vote in the group and you guys let me know what you guys think I should do. That is really your marathon. You tell me what to work out and I'll be here with you. All right. So we're off to a late start. But we're going to dive into this particular paper. And last week, you guys would have done a lot of talking about what our objective is, how much questions you need. You know, we did all of that talking last week, so we don't have to do it again. Here you're seeing the front of the paper, a familiar look that you need to get used to, right? Where it basically tells you, give me a sec here, guys. It's not coming up. Give me a sec. Okay, here it is. As you would have seen from last week here, me. All right, so as you would have seen from last week here, right here, you'll see that the exam is what? 2 hours and 40 minutes long. I'll discuss how important it is to break down that time so you can actually get a chance to do the full paper. Instructions are already there. And this is a formula sheet that they give to you. Last week, from the whole entire paper, only 2 formulas we utilized from it. And it didn't really help us much because we still had to know what we were doing. All right. So we're going to be running from 9 until 12. Well, obviously from 9:30 until 12. And then we take a break at 12. Y'all go do whatever it is that you do. And then we'll be back at 1. Hopefully, whatever questions is left, we can work it out. I would love to start from the back of the paper. Unfortunately, because there are some topics that I have not yet taught you, it's kind of going to make everybody a bit uncomfortable having to, watch like a show and tell type of thing. So for now, for the first 4 marathons or so, giving me some time to complete the syllabus in the regular teaching, I will be just working the papers from the front. All right. As per usual, guys, please, if you have any questions, please ask them. If you see something that's being done and you're not clear, don't bother depend upon the recording. Right? The recording is good enough. But you see me now, I'm live, I can talk to you. Tell me, say, sir, you do something there, I don't quite get it. Can you do it over? Please use the microphone on the chat. All right. This is what you're here for. This is what you paid me for. To explain concepts and make sure you get it clear. Not in the recording, in the live class. All right. So we're going to dive right into it. Starting off with obviously the easiest questions on the paper. And let's get into it then. All right. So section 1, you're to answer all questions. Well, you're to attempt to answer all questions. All right, so just give me 1 second, guys. Just give me 10 seconds. I'll be right back. Safani, I'm already recording the class there. All right, I am back. All right, here we go. All right, so first question. We are to calculate the value of the square root of 7.1 squared plus 2.9 squared, and you're to give your answer correct to two significant figures. All right, so not a bad question to start, right? So all we're going to do, ladies and gentlemen, is use our calculator, right? And we're going to work out this section, work out that section, and then we take the square root of the results when we add them. So don't type everything on your calculator at once. That doesn't show that you get the work. Even though it's only 1 mark, you still want to show them that you're doing some sort of work. So you can go on your calculator. I need some calculator persons in the class as well. Right, so somebody can tell me what is 7.1 squared, please. I'm going to use my calculator as well to keep up with you.
50.41.
So you're going to write square root of 50.41. Oh, give me how this looks. So all right, so that's going to be square root of 50.41. All right, plus what is this square of 2.9? What's the square of
8.41.
8.41. All right, so you're going to go ahead now and add them. So notice I'm doing my questions in steps, I'm not trying to rush it. So that should give me, I believe, 58.82. Confirm it, please. 58.82.
Yes, sir.
All right, and then the final answer, what is the square root of that result?
It's 7.669.
7.669. 7.669. Not sure. So therefore now we need to figure out a way now how to round this off to two significant figures. So what does two significant figure mean? Two significant figure meaning that I'm looking for the first two digits that's not a zero. And obviously that number would have been 7 and 6. I would draw my line right here. Well, between it actually. All right, then I will check the number that comes after. The number that comes after that line is greater than 5, so I would definitely increase this 6 here by 1. So my final answer would have been 7.7 here. All right, so that's your solution there, 7.7. So practice to work out the stuff that are inside of a bracket or they're under a square root. Work out whatever is in a bracket or under a square root, and then you take the square root of the final result you get. And depending on what them say round it off, then that is 7.7. All right. Now them also say you must round it off to 2 decimal places as well. So we're gonna go back up here. Same answer. Our answer that we got before was actually let's see. So our answer that we got before was 7.669. We had to round off the answer to 1 dp. Well, 2 dp. So 1. So this is the first 2 dp here. Draw my line there. Check the number that comes after. That number also is greater than 5. So I'm going to add 1 to this 6 right here. So my final answer for this is going to be 7.67 instead. All right, so to 2DP, it is 7.67. To 2 significant figures, it is 7.7. Okay, everybody clear on that? Any questions there? Just like it warm up,
No, sir.
Oh, so no
No,
question.
no questions. Yeah.
All right, good to go. Now, our next question says here that we should write the following quantities in ascending order. All right. And hopefully, I'm trusting that everybody knows that ascending means going from small to large, right? Ascending, you're going up. So from the smallest number to the largest. Now, when you get questions, if and when you get questions like these, it's a little easier to see when a number is small or large when it is in a decimal form, right? So if you can get a chance to turn every number into a decimal, that would be good. All right, so I'm going to go on my calculator. I'm going to type in 12 divided by 25. And my calculator is telling me that the answer right here is 0.48, right? And then I know that the next number here is 0.46. 0.46. Now, how would I? Somebody wants to come into the class, guys. Give me a sec. Anisha, Shiniko, okay. All right, so 12 divided by 25 is 0.48. And then we have 0.46 right here. And then how would I convert 47% to a decimal? Well, percentage is out of 100. So that means I would have to naturally then divide 47 by 100 because I had to multiply it by 100 to get 47%. So if I divide it by 100, I will end up getting 0.47. So from this point of view now, it's very easy to figure out which one is the smallest. You can see what that 0.46 is the smallest. Then you have 0.47, not true? And then you have what? 0.48. Now, if you write the answer like that on the screen, you're not going to get the mark because we are the one that converted this thing here to a decimal. And we are the one that converted this to a decimal, right? So we'd only get a half mark for this right here, right? Because the conversion that we did was just to make it more obvious as to which one is small or large. So the 0.47, we would have to erase here and put 47% because that's what they gave us. All right. And then over here, the 0.48, we would have to erase that. And we would have to put, would have needed to put 12 divided by 25. All right. So that would be your answer. All right. So 2 marks easily, 12 divided by 25. Remember, guys, when you're trying to figure out if something is small or large, your best bet is converting everything to a decimal form. And then you should be okay. All right. Any questions on those two so far? Nothing? Not yet? Everybody Gucci? All right. The easy part of the paper, this. So you guys should be okay. Should be. All right. So part B of question 1. Mahendra and Jaya shared $7,224 in the ratio 7-5. The question says, how much more money does Mahendra receive than Jada? So we want to know the difference between the two shares, right? Now, I'm assuming that some of you can recall that I gave you a 3-step process to solving any ratio question. All right, let us just recall those steps if we can. Step 1 is to always write down the comparative quantities. So in this case here, we're looking at Mahendra, that's M. We're comparing that to Jaya, which is J. All right. And then we were told that the split of the ratios is in the ratio 7-5. 7-5. Now, what happens when we get a ratio, whether now or in the future, right? What happens when we get a ratio is that we need to find something known as the TP. So the TP is known as the total proportion, which in this case, you're going to go ahead and add 7 to 5. You're going to end up with, say here, 12. All right, so that means this 7,224 was divided into 12 equal parts. So we're going to go ahead now and see what is 7,224, and we're going to divide that into 12 equal parts because we want to know what's the total for each part. All right, so help me out now, guys. 7,224 divided by 12. What are you guys getting? I'm getting 602. Can you confirm that?
Yes, sir.
Yes, sir.
Right. Good. As you're getting $602, right? Now, some person will go ahead and try to find out what is Mahendra's share and then find out what is Jaya's share and then subtract it. That can be done. But since as you look at the ratio 7 to 5 right here, you can clearly see that Mahendra got 2 extra shares than Jaya. Not true? Because if Mahendra got 7 and Jaya got 5, it's very obvious that Mahendra would have gotten an additional 2 portions over Jaya. So therefore, all I have to do now is that since I know that Mahendra has 2 extra shares than Jaya, and I know that one of those shares is $602, I just have to go ahead and multiply 2 by 602. And then I would have known that here it is $1,204 extra. So therefore, what this is saying is that Jaya would have received $1,204 more than, sorry, Mahendra would have received $1,204 more than Jaya, which is what they ask us. How much more money does Mahendra receive than Jaya? Okay. All right. Everybody clear on that?
Yes, sir.
Right. Make sure everybody go through, remember these little steps. Then make a ratio something here, write down the comparative quantities, write down the ratio, find the TP, those little things. Even if you're not sure what you're doing, make sure you write something down on paper. All right, don't leave it blank. All right, just stick with the routine, stick with the plan, and everything will be okay. All right, moving right along to the next question. The present population of Portsmouth or Portmouth is the present population is 550,000, right? Now it is expected that the population will increase by 42% by 2030. You are to write the number 550,000 in standard form. All right, so this now is another concept that may have slightly flew over our heads when we just started class. Now let me bring you back to that lesson. When a number is in standard form, the number is said to be in the form a multiplied by 10 raised to the power of n. All right, please make a note of that, guys. When a number is in standard form, when you basically what we're trying to say is, if I write a number down on paper and the number looks anything like this, then that number is said to be in standard form. So the question then is, how do we get a random number, Mr. Peart, to put it in that form? First, you have to know what is a, and then you have to know what is n and how you get them. Notice that 10 is a constant, so that doesn't change. Now, what is a? A. A has to be a number that is greater than or equal to 1, right? But at the same time, it has to be, all right, so let me just write it this way. All right, so what is A? A has to be a number that is greater than or equal to 1, but at the same time, it has to be less than 10. So it can be 1, it can be any number after 1, but it cannot be number, it cannot be 10. The maximum it can be is 9.9. So whatever you do to this number up here, whatever you choose to do with this number up here has to end up being, this number has to end up being less than 10 or at least greater than 1. Now, the next thing that you need to figure out now is what is n. Now, n represents the number of places that you move the point. So n represents the number of places that the point was moved. So the number of places that the point was moved. So the number of places that the point was moved. Sorry for my bad handwriting, guys. So let's get to the question then. 550,000, right? The first question now a student will be asking, sir, where is the point? I see a comma. Well, in fact, you don't even see a comma. I mean, you put it there. Right? So let's just remove that there. The comma wasn't there. So the question then is, where is the point, Mr. Peart? Now, whenever you get a whole number, right? Whenever you get a whole number, the point is at the very end, out here. So whether you see it or not, the assumption is that the point is right here. So watch me now. I'm going to jump the point. I can't move the point this way because I'll be making the number bigger. Not true? The more zeros you have, is the bigger the number is going to become. Yeah? So that means I have to jump the point. Now watch how far I'm going to jump the point. I'm going to jump 1, 2, 3, 4. If I stop there, the number is now 55. That is still not less than 10. If I jump again, then the new number now becomes what? 5.5. So can you confirm that 5.5 is greater than 1? And at the same time, it is less than 10? Everybody can confirm that?
Yes, sir.
Yes, sir.
Good. Notice now that I'm going to just simply times this by 10. I'm going to times it by 10. So 5.5 times 10. So is it always times 10? Yes, it is times 10. Now, the next thing now is, what is n? Now, as you can see from the instructions here, that n represents the number of places that was moved. Now, how many places did I move? Look at it. 1, 2, 3, 4, 5. So the question is, do I put down a positive 5 or do I put down a negative 5? That's the question. So all of this is in the subtle mistakes, guys. People get these 1 mark question incorrect because of subtle mistakes. So do I put positive 5 or negative 5? Well, I'm going to drop a little thing here for you. Positive 5, that is correct.
Yes.
So when it comes to standard form and you jump your point towards the right, even though on the number line right it's positive, standard form is the opposite of the number line. So it's going to be negative if I jump to the right, but if I jump to the left, it's going to be positive, as Miss Gentle says. All right, so my answer then is going to be 5.5 times 10 to the power of 5. Okay. All right, everybody go through with that question. Everybody
Yes,
go through?
sir.
Yes, sir.
Yes, sir.
Wonderful, wonderful. All right, so just make notes, anything that you're learning for the first time, right, or anything that you're seeing for the first time, or anything that you're recollecting for the first time, you just make a note of it, so that as you're going through the recording, you can, kind of remind yourself of what it is. Oh, speaking of recording, remember, ladies and gentlemen, that the soft copy for the paper that we did last week is already available. You just have to message me for me to send it to you. Okay? All right, lovely. Moving on to the next question then. All right, now, so that was just converting that 550,000 to standard form. Now it says here, calculate the expected population of Portsmouth in 2030. Now, following down, guys, remember that we had some instructions up here. Don't get lost in the calculations now. We were told that by 2030, it is expected that the population is going to increase by 42. So there's 2 ways to look at this, guys. Remember that everything at its original value is 100%. Anything at all at its original value is 100%. So if you want, you could just go ahead and add 1. You can go ahead and add 42 to 100. So you could say 100. Oops, sorry guys. Oops. So you can say 100 plus 42 and divide it by 100 and then times this by, say, 550,000, because the population will increase, So the population is no longer going to be at 100%, it's going to be higher. So this is 142 over 100, and you times it by 550,000. Now, pay attention to the marks, guys. You see the marking scheme right here, so it tells you how much work you really have to do. A question that is worth 4 marks or 5 marks is a lot of work. The most marks CSET gives for a question is 4. So enter your book up on a 4 marks question, it's going to require thinking, it's going to require calculation, it's going to require one formula. The 1 mark question them is nothing too crazy. Okay? So go ahead, guys, and punch that onto your calculator. So that's 142.
That would be 781,000.
Give me a second. Let's delete this. Okay, fine. So yeah, 781,000.
Mm-hmm.
So therefore, by 2030, we are expecting the population to be 781,000. All right. So that's one way of working it out. But you know my style already. I don't give persons and say this is the way it has to be done. No, you have other ways as well. So if you want, you could have just simply said 42% over 100 and times it by 550,000, right? Blah 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 blah. And then when you get your answer here, you add it back to the 550,000.
Oh,
Right. So you could have done it that way as well.
that's what was popping in my head first. And
Yep.
then, yeah.
So 42 divided by 100 and you times it by 550,000. You should get 231,000. All right. And then you just simply add that back to 550,000. And you'd end up with the same answer, 781,000 here. Okay. And that's where we're at. So once you can do that, you should be okay. All right. So different techniques, based on what the question is asking. Based on what the question is asking, then you can use a particular approach. For me, because they weren't asking me how much was the increase, and I didn't need to know what the increase was. All I wanted to know was the end result. That's why I used this method. But if they had asked me that the population is going to increase by 2030, how much was it increased by? I would have used this method. So it's just kind of personal preference. Okay. Mattis, the exam is on May 12th. Oh, she's not in the class. Oh, wrong Mattis, my message. Okay, give me a second, guys. May 12th. Okay. I'm moving right along. So everybody go to there, sir? Everybody all right? Everybody comfortable with that point?
Yes, sir.
Okay. All right, so we're going to go to this little graph thing here. Don't get scared now when you see the graph. It's just a matter of understanding what the graph is saying. So it says here that the graph below can be used to convert between the US dollars, which is US dollar sign, and Eastern Caribbean dollars, which is EC. All right. So according to the question, it says you have to use the graph. So whichever other method you think you can try use, you won't get the mark if you don't show it on the graph. So use the graph to convert 2 US dollars to EC. So which of the axes contains the US dollars? Right here. So this axis contains this thing right here, right? So what I'm going to do is that I'm going to grab my red marker here. All right, I'm going to try to zoom up for you here. And no, follow me now, I'm going to run a mark from the US dollar right here. And all I'm going to do now is just stop it with touch the line. Hold on, I think I might need to use something else. Hold on. Let me just undo this. All right, so I'm going to just go here. Right, this sir. Let me see the part it stop. Oh, yes, sir. Not fully accurate though. And then I'm just going to just send the arrow come down here, so. So it look like we have got estimate for the number they be. Now let's see now. So let us think now, guys. All right. What does that represent? We know say between 1 and 2. Well, 1. So basically everything down here is moving up by $1, right? And you can see that there are 5 lines between here, so each of those lines, if you think about it, should be about 20 cents. Not so? Right? Because you're going to have $1.20, $1.40, $1.60, $1.80, then $2, right? So every one of those lines between the numbers would represent 20 cents. Not true? Everybody in agreement based on the... Everybody's in agreement?
Yes, sir.
If I'm at $1 and I'm trying to get to $2, but there's 5 lines in between 1 and 2, this has to be $1.2, 1.4, 1.6, 1.8, then 2. So when you're reading the graph, you have to, based on the scale that you're given, you have to read the graph accordingly. All right. So here you can see that our arrow going down is 2 strokes after 5. And if each stroke represents 0.20, then the second stroke would represent what? 5.40. So we can confirm then based on this. Right? Once you draw your little arrow thing there, so it don't have to be an arrow, but a line to show it, you can clearly see that the answer right here is going to be $5.40. So $5.40. Now here's where you lose the mark now. If you don't write EC, you finish. Well, I'm not gonna know if you'll get it wrong, but I just think it's better if you just say EC $5.40. Because of that, them ask if I know them say you should convert the $2 to EC. That means you should state your answer in EC. All right, everybody go through with that?
Yes, sir.
Yes, sir.
All is good, all is good. Okay, all right.
Sir.
Question so far. Cool. Moving on. Same thing, same instruction, ladies and gentlemen, folks. It says still use the graph. But one instruction is up here, and then questions follow. So every question underneath this heading right here, you have to follow that particular instruction. Okay? So don't go try use nothing too funny or go outside of what them ask you to do. Alright, so now we have to convert EC $70 now to what? Convert EC $70 to US. So now we're gonna go the other way now. So I'll grab here, so get a blue marker. Alright, so we're 70 now. Remember say, oh, but hold on. It says EC $70. Alright, hold on. Because it just say EC 70. I not see 70 on the graph. Is the case where I have to assume that this is $10? There has to be something here. Hold on there, guys. Because is this a case where the numbers, I need to figure out, is the numbers down here saying that the 1 represent 10? EC $70. The question is, I'm not seeing anything on the paper that suggests whether or not this represents, like you know, like it does say 1 represent 10. I don't know if that they mean. There's nothing on the graph that's saying that. The graph below can be used to convert US dollars to Eastern Caribbean dollars. It didn't really specify. I know, so up here saw 1, 2, 3 US, and down here so must be 1 EC. What would I do here? If I'm in the position right now, based on what you're asking me down here, because clearly 70 is not here. The question is only worth 1 mark, so it's nothing heavy to think about. It won't be anything too crazy. So my intuition would tell me, based on what you're asking me, I can't see $70 on this graph here. So the only logical reason here would be that I have to assume that each of these would have to be 10. So that would be $10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's my only assumption. There's no other way to there's nothing on the graph or nothing in the instructions that said that. So naturally then, I would have to assume that if they're asking me for 70, it would mean that I have to use this number right here, this 7 here. All right, so that me gonna do. All right, I'll double check it to see if that's what the instructor online did. But I'm just gonna work with that. So I'm just gonna go here. I'm gonna run it up from here. Stop it there, so. Let me go run it across again now. Like that. So that's the only logical assumption we can think about. So now you can see, all right, so that means if that's the assumption I'm using, then that means this answer go wrong then. This answer cannot be 5.40. It has to be $54. Because this would be 50. And then each of these represent $2 then. So if that's the assumption, I hope you guys are following me and the reasoning we are coming in place, you know.
Yes, sir, I'm following because I was wondering the same thing if you would have to change that one as well.
Yeah, this would have to be $54. Yeah, if that's the assumption we're using, then it has to be 54. This would have to be $54. Why am I doing this? So logical reasoning then, I would have to say that this is easy $54. If that's the assumption we're using. But if it's safety, I mean, I wouldn't even say for safety because when they ask me down here, so it's 70. And I don't see 70 nowhere down here. So the only logical assumption would that this would have to be represent the 70. So that may I work with. If it's wrong, then there has to be there. That means the information given to us is inconclusive. All right, let us figure out what this side of the US dollar mean now. All right, so let's see what each of the US dollar mean now. So obviously, if we're between here and here, let's see, if we're between here and here, that means that each of these have to represent 20 cents. Because this is 20 cents, 40 cents, 60 cents, 80 cents, then a dollar. $1.20, $1.40, $1.60, $1.80, $2. That's all. So it looks like we are what? We are 3 lines above $2. So that would have to naturally be $2.60. So this would have to be $2.60. Using the graph, $2.60. So US $2.60. I'm still kind of feeling not too convinced. Sorry. I'm not feeling too convinced about the final answer that I've chosen. Give me a second, guys. Hold on. All right, so I'm not really feeling too convinced about the answer. I will verify this in our break session. I'm gonna stick with this for now, but I don't have enough information to work with. You're not even telling me that this is like they're not saying to me whether or not the $1, the one here represents $10. So if that's not the case, then maybe some conversion I forgot about. Why would they give us only 1 mark to do all that work? So not quite sure yet. All right. So just bear with me and then I'll let you know in the second session. All right. So moving on, if there's no question on that. Number 2. So we're already gone. I'm just gonna assume that we're gone 8 marks out of the 9. I feel like I got that last one wrong, but we'll just work with 8 out of the 9. All right. That's still a lot of marks to get. All right. So Laura needs to put mesh around 2 seed beds to protect her seedlings. Let's read it again. Laura needs to put mesh around 2 seed beds to protect her seedlings. Now, notice that there's some words that are bold, guys. This word here, altogether. There's a reason why them do that. So pay attention. Altogether, she uses 60 meters of mesh. One of the seed beds is a rectangle and the other one is a square, as shown in the diagram below. So assuming that you guys know that a seed bed has to be basically a portion of the ground where you plant your seeds in. Just give me a sec, quick there. Simon.
Sir.
Yes, go ahead.
Can you get back, please?
My apologies, guys. All right, so we don't really care about what a seedbed is. All we just care about is the mesh that she's going to do. Now, the key word here in this question is altogether. What we know is that Laura has 60 meters of mesh. So basically, she's going to use some of that to wrap around here. So, let them say around, is a mesh. And she's going to use the rest to put around here. So make sure you understand what she say. So both of those black things that I put around the shapes, right, will represent a total of 60. All right, let's continue. Now, it is shown here that the width of the rectangle is x meters, which you can clearly see right here, x meters. And the width of the rectangle is x meters, and the length of the rectangle is 3 times its width. Go interpret that first. So we know that the width, which is right here, that I've circled in red, is x meters, and the width is going to be 3 times that size. Can you tell me what you think this side is going to be? If the width is x and the length is 3 times that size, what do you propose that the length is going to be?
3x.
Very good. All right. So this is what Csec talks about interpretation. All right. So we're going to have to make a logical assumption here that this length has to be, say, 3x. So when you're working these questions, ladies and gentlemen, when you're working these questions, as you don't read the whole of the question and confuse yourself, as you read a particular line, try to see if you can interpret it at the same time. So that's 3x, all right? Continuing. The length of the side of the square is y. What information do you know about a square? What is it that you remember about a square that you've been taught?
All
That
sides.
all the sides are equal.
So it's safe to say that this side is also y. Hold on. Is it safe to, do you agree if I say that this side is y, that side is y, and this side is y as well? Everybody in agreement?
Yes, sir.
Yes, sir.
All right, cool. Now, if we are in agreement, then it says using the information given above, you're to derive. That means you have to come up with a simplified expression for y in terms of x. For y in terms of x. And it says an expression, not an equation, so no equal sign of involve. Now, remember we're talking about perimeter, we're not talking about area, we're talking about perimeter. Then I mention nothing to you up here about the area. So for a rectangle, we can confirm that this side is x as well, because the opposite sides are equal. And this side down here has to logically be what? 3x as well, because opposite sides of a rectangle are equal. So they gave us the width, we derived the length. That means the other length has to be 3x and the other width has to be x. And for the square, one side is y, and because we know that all sides of a square are equal, we put y's around everything. Not true? So it says here, using the information given above, you are to derive an expression for y in terms of x. So therefore then, I can say 3x plus 3x plus x plus x. That's going to give me the perimeter of the rectangular seedbed. And I'm going to have what now? Plus y times 4, because of 4y. 4y is there. That's all. So what is 3x plus 3x? That sounds like 6x. 6x plus another x right here. That's going to be 7x. 7x plus another x is what? 8x. Not sure. 8x. Let me just write it a little better. All right. And then we end up with y times 4 is going to give us what? 4y. That's it. Nothing more is there to do. Nothing was mentioned about area. Nothing was mentioned about area. The only thing that was mentioned here is that they're saying up here that Laura needs to put mesh around. So the keyword here, around, me know say that has to do with circumference. All right, so that's the keyword, circumference. They didn't say an equation, so there's no point in me putting equal to 60 here. So there's no point in me doing that. So we're just kind of making sure that whatever we write down, we convince ourselves say it right. All right. So everybody, you feel like we're comfortable, we can move on? Are we confident in our answers? Is everybody comfortable with the answer moving forward?
Yes, sir.
Quick question, Mr. Beard. So when it says for y in terms of x, we're supposed to use both.
Yes. So what? Well, let me say y in terms of x. Yeah. So y and x has to be involved.
Okay.
All right. That's also a good question too, you know. Because normally, who is that just said that a while ago? Jadia. That's a very good observation too, you know, Jadia. Because normally when C6 says y in terms of x, you know, they normally involve an equation. Because whenever them say y in terms of x, it means that we want y to be by itself and everything else should be on the other side. That's a very interesting point of view, you know. All right. Well, it says altogether, she needs 60 meters of mesh. One seedbed is rectangular and the other one is squared as shown below. Altogether. I'm thinking, Shaded, I think you're right, you know. How much marks is it worth? 2? Jadia, I think you're right, you know, dear. I think it's going to be 8x plus 4y equals 60. And then now we need to get y by itself. So even though them never say equation, because this throws me off a while ago, you know, them say expression. So normally no equal sign is supposed to be involved. But all right, I'll work with that then. Thank you, Jadia. So after we add up the two things, ladies and gentlemen, I think we have to equate it to 60. Considering say it worth 2 marks, it means say this can't give you 2 marks. You can't just add them something there and get 2 marks. So let's go ahead and get y by itself. I'm going to go over here and I'm going to transpose the x. So I'm going to end up with 4y. I'm going to end up with 4y. Oh, sorry, guys. So I'm going to end up with 4y being equal to 60 minus 8x. And then now, to get the y by itself, as Jada was saying, we need to have y and x involved. But y has to be by itself because him say y must be in terms of x. So that means that when you get y, the answer you get on the right side should have x in it. So we're going to go ahead and divide by 4. What is 60 divided by 4, guys? I think that's 15. Confirm it.
Yeah.
15. And what is 8 divided by 4? Yes, you can see that that's 2. Okay. So I think you're right, Jada. I remember working this question some years ago, and I remember that this is what I got. So good identification there. Very good. So that's your answer, guys. 15 minus 2x. For those of you who are wondering how you would know to do that, well, you know, now that I've taken her thoughts into consideration, I was wondering where the 60 was going to come into play. Because why would they give us something and I'll know when I use it? So, yeah, man. Good observation, Jada. Good job. Jadia, good job. All right, so everybody go through with that. Everybody's good with that? Everybody
Yes,
okay?
sir.
Yes, sir.
All
Yes.
right. Dope. All right, good. Moving right along. Now, remember now that a y now. Let's go down here. Now, you see them start talk about now? Them start talk about area now. So they're now saying that the area of the rectangular seedbed, and notice which word them highlight. They put in a bold, equal. So they're trying to emphasize on the fact that this sign now is going to come into play. So they're now saying that whatever the area of the rectangular seedbed is, it should be equated to the area of the seedbed. And then you have to use the information, and the answer where you get in part A, you have to write down a quadratic equation in terms of x and show that it simplifies to this. So when students see this now, they'll be like, Jesus have mercy. How do I do this? It all comes back down again to 1, experience, understanding these types of questions, and 2, being able to read and comprehend. So you know what we're going to do? We're going to go ahead and we're going to just work it line by line. Whenever you get a difficult math problem, you work it line by line and let each line lead you to the answer. So I'm going to go ahead then. Oh, sorry. Oops. So I'm going to go ahead then and attack the question from here. Hold on there. Okay. I'm going to attack the question from here. So first, them said the area of the what? Rectangular seedbed. Let me attack that part there first. Go back up here. Let's look back at my seedbed. How would I find the area of this rectangle? Remember earlier I found the perimeter by adding up all the sides. What would you do if you had to find the area of this seedbed?
Sir, of the rectangle one.
Yeah, the rectangular one, yeah.
Multiply length times width.
Good, very good. So you multiply length times width. What happens when you multiply 3x times x? What do you get? What do you think you get?
3x squared.
All right, lovely. So let's write that down. So you can state now that the area of the rect is equal to 3x squared. Cool, no problem. Not true? All right. And now we're going to look now at the area of the square bed. So the area of the square bed, all right. Let's go back up to our square. So hold on, let me just highlight this part now. It says to the area of the square seedbed. Go back up here now and look back at our square seedbed. What would you do now to find the area of a square?
Times the side by side.
Again, that is correct. Times the side by the side, which is y times y, not true? But the question then is, we don't know what y be. Or do we? What is y? 15 minus 2x, not true? Do we agree?
Yeah.
If someone
Yes.
choose the answer in a part A, and this is part A, right? That's all. This is part A. So them so must use the answer that we got in part A. That them say, right? Them say use your answer in what? Part A. So therefore, because we know so the area of the square here, as the student suggests, is y times y, we then know that it has to be what? 15 minus 2x multiplied by 15 again minus 2x. Now say go. Everybody with me? I should say everybody with me now. Don't lose me now. Everybody go, Chi?
Yes, sir.
All right. Now, what do we do now when we end up having to multiply two algebraic brackets by themselves? We have this technique that was taught to you called FOIL, foiling. We will use the first to multiply the first to multiply the second to multiply the first. Sorry, the second to multiply the first, right? And the second to multiply the second. Anybody can recall that method that was taught?
Yes, sir.
Yes, sir.
Let's go ahead and do that then now. So 15 multiplied by 15, that's going to give us 225. Not sure. You can see already we're close to our answer. So that the first multiply, we can see that the answer is coming. But let us finish it though. So 15 times 15 is 225. 15 multiplied by negative 2x is going to give us negative 30x. Then we're going to do the same thing here. Negative 2x times 15, that's going to give us another 30x. And then obviously negative 2 times negative 2 is positive 4. and then x times x is x squared. Not true? So this simplifies now down to what? 225 minus 60x, because them two here in the middle, they are like terms, plus 4x squared. All right, now what did they, so let's go back up here. The only thing we left off now is this thing here. Not true? Them said the area of the what? Rectangular seed bed, which we now know is this thing here. So now we know says 3x squared must be equal to, them say the area of the what? Square seed bed, which we just worked out to be what? 225 minus 60x plus 4x squared. All right, so we need to simplify that now. And if our simplification is correct, then everything should boil down to this. But we can see it already, right? We need everything to be on the what? Over here, on the right side. So I'm going to have, all right, you know what I'm going to do? I'm going to just carry, because I only one term over here, I just carry this come right here. So. All right, so I'm going to end up with what? 225 minus 60x plus 4x squared.
But sir, you don't have to equal to 0.
Yeah, man,
So
because
you have to put it.
Yeah, not now left over there.
So the 0 can go on the other side?
Yeah, man, it can be. Yes, of course.
Okay.
Yeah.
All right.
So that's minus 3x squared. So when you work out this one, we're going to get 0 is equal to 225 minus 60x plus x squared. And that reduces to this thing up there. All right, everybody go, Chi?
Yes, sir.
Any questions, Shaniqua? Good? We know not talk, you know. And then no say not understand. When we say not understand, you know. And then we go say what's hard. I'm asking you now, is everybody okay?
Yes, sir.
All right then. All right.
I'm getting it, sir. I'm getting it.
Okay. Good. Good. All right. Now, since everybody is good, then so must move to the part where we need to solve the equation, but we need to do what? Use the quadratic formula. Now, so that them say, right? Use the quadratic formula. So now this is our first hint now, ladies and gentlemen, of where we're going to run. Because obviously, if you see quadratic formula, when the nerves start lick you, you're not even going to remember what is a quadratic formula. May I tell you that? You're not going to remember. So here what you do. Just run, go back up yourself, and see if you see it. See if you see it. In the day. See it there. You see it? Let me help you highlight it for you. So do you see it right here? X equal minus b plus or minus the square root of b squared. This thing here is when them say, look at it, it's when them say roots of the quadratic equation. When them say that, this is what them call the quadratic formula. But this is the general form when you are factorize. But when you are solve, that's the one that you use right here. Okay? So we're going to leave those in red because this is the first time we actually have to use the formula. So we're going to grab this thing right here, right? I'm going to grab this thing here, and we're going to use that formula down into this question down here. All right, so we're going to grab that formula. And we're going to say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? So now you need to figure out what is a, b, and c. So remember now, all right, the number that is in front of the square is a, the number that is in front of the x is b, and the number that is all by itself is c. Please note I did not say that A is at the front. I'm putting that out there because the class is being recorded. I did not say A is at the front. It just so happens that A is at the front now. But me no want when them, I don't want, if them switch up the question for you and do this to you and say 225.
Excuse me,
Minus,
sir.
yes.
Sorry to stop you. It's Zahina here. Somebody who is trying to get into the class, somebody's trying to get into the class, however, they don't have the link. So they're trying to reach out to you, but since you're in the class, you're probably not seeing it. So they're asking that if you can please respond to them.
Okay, give me a sec. I think I just see it. Is Aria White?
Yes, sir.
Okay, all right. Tell her that I'm going to send it to her. Now, give me a sec. Hold on. That's 237. 237. Give me a second, guys. 237. All right. Tell her that she can check her WhatsApp now. I just sent it to her.
Okay, sir. Thank you.
You're welcome. Give me a second. Hold on. All right. All right. So back to what I was saying here. I don't want, if in the future when you see a quadratic question, you're seeing 225 minus x squared, let's say plus 60x, and then you go say, Mr. Pierce, so this number is A, and that number is B, and that number is C. Please note once again that the number that is in front of the square is the number that represents the letter A. The number that is in front of that is in front of the X represents B, and the number that is by itself represents C. So I just want to put that out there. Okay? So please take note of exactly what was said. So what number do you see appearing before the x squared? Or what number do you think is in front of the x squared?
1, positive 1.
Very good. So therefore we can say that A is equal to 1. And obviously the number in front of the x is going to be B, which in this case is minus 60. And the number in front of, or the number by itself, which is C, is going to be 225. All right, so we're going to go ahead then, and we're going to plug those numbers into our formula, and then we're good to go. All right, 225. All right, so now x then will be equal to negative of negative 60. Watch carefully. So it's, remember now, it's negative b now. So it's negative of the value of b. So it's the negative of negative 60 plus or minus the square root of b squared. So b squared is negative 60. Now careful now, guys. Put the negative 60 in a bracket. You don't know who your marker is going to be. Now if I'm marking your paper and I see a student put negative 60 squared without the bracket, I'm marking the question wrong. Without the bracket, guys, negative 60 squared is not the same result as negative 60 all squared. In college, you get crucified for that. I know you're not in college, but I'm just saying at a higher level, you can't do this and get away with it. So make sure, so when you put down any negative number, you put in a bracket if you're going to square it. Okay? And then we're going to have minus 4 times A. So minus 4. Oops, sorry guys. So that's going to be square here. So that's going to be minus 4 times A is 1 times C is 225. And that's going to be all over 2 times A, which is going to be 1 again. All right. Punch this in now. X is equal to, use up our calculator as best as we can. It's going to be positive 60 plus or minus. Now, go ahead and square 60 for me. I think you guys should get 3,600. Confirm it, please. Confirm it.
3,600, sir, yes.
Correct. And go ahead and multiply 4 times 1 times 225.
$900.
That's minus 900. And everything will be divided by 2. All right, proceed again. X is equal to 60 plus or minus. Can we confirm that this is going to be the square root of 2,700? $2,700?
Yes, sir.
And that's all going to be divided by 2. Continuing, right? Like I said, you guys can do it more. You can take multiple steps, you know. You don't have to do it like me, you know. But remember that I have a lot of audience that's watching this, so some persons are going to need the steps. All right, so go ahead and find the square root of 2,700, please.
That's 51.96.
51.96. That's going to be all over 2. So we could do a split now, Miss Gentles. We're going to have to say x can be equal to 60 plus 51.96 over 2, or x are equal to 60 minus 51.96 over 2. One of those will be our right answers. So go ahead for me now. So just go ahead and type everything on the calculator. Well, not all at once, you know. Don't do it all at once. Do the top part first. Press equal and then divide by 2. Do the top part first. Press equal and then divide by 2. So waiting for the answer.
I'm getting 4.02.
4.02. Somebody is getting that as well?
For the top one.
Yes, sir. I got that for the last one.
For the last one or for the top one?
The answer was 8, and
I get that for the plus one.
Hold on, which one of them is the 4 point something? The bottom one?
Alright, for the bottom one, sir, I got 8.04 and I divided it by 2 and I get 4.02.
Alright, and for the top one, what did you get?
Didn't do the top one.
Okay. Alright, so somebody go ahead and do the top one, please. Guys, not finished yet?
55.98, sir.
55.9. I wonder if it takes so long. Come here, multitask.
Sir, I was talking with the mic.
Oh, okay. So 51 point, how much?
55.98.
55.98. 55.98. All right, good. Now, the question then is which of, they never say we must choose which one, them just must solve the equation. So therefore, that's our answer. So answers are going to be what? 55.98 and 4.02. Okay? That is our answer. Give me a second, guys. Me have to multitask. More than one persons are trying to join the class. So forgive me.
Excuse me, sir. She's trying to come into the class. So can you please let her in, please?
Yeah, I was waiting for her now.
Oh, okay, sir.
So she's Zoom user. Oh, so she was the one that I was asking what's her name. All right. Alia?
Yes.
Oh yeah, you were the one that was in the class earlier by the name of Alia White.
Yes, sir.
I was
Aria.
asking, but you never respond. So I thought it was just somebody from the outside. My apologies here.
Yes, sir.
All right. Okay. All right, good. All right, so everybody go here now. All right, so that's it. Now the question then says now that we should calculate the area of the two seed beds. Calculate the area of the two seed beds, right? So we have to go back up here now, and then we have to figure out which one of these is the right answer. Now, I wonder which one of my students then can tell me which of these would we choose for the answer. Would we choose 55.98? Two of them is the answer to the equation, but only one of them can give us the correct area. Let us talk about it then. Let us re-sketch back this thing here. So here, we have the rectangle. I wonder if somebody can really analyze and tell me which one of them are the right answer. So right here, I have the rectangular seed bed. Right? And we know that each side is what? Sorry, one side is x and the other side is what? 3x, not true? And then we have the square seed bed here. Right? We have the square seed bed, but we know so each side is going to be 15 minus 2x. So the question is, I'm going to test and see what would happen if I use 55.98 for x, right? Remember, so we don't know, so this square seed bed is y times y now, but remember that we had said earlier that y is actually equal to 15 minus 2x. So with that information then, because we know so it's y times y, we know it naturally has to be 15 minus 2x and 15 minus 2x. All right, so the question then is, which one of these would I use? Would I use this x or this x? I'm gonna go ahead and use the 55.98 and see what happens. So this would then be, all right, so go ahead and multiply 3 times 59.28, 55.98, please. What did you get? 2 marks, so critical thinking requires. So let's go ahead and use 55.98. What is 3 multiplied by 55.98?
That is 167.94.
167.94. All right, and then that would be, I'm so sorry, guys. Give me a minute. Hello? Yes, I got a missed call. I'm not sure. Hold on, give me a sec. Trying to figure it. Give me a sec. Is this Carla's mom? Kedra's mom. Did they give you like a yellow pass or a receipt or something like that? Yeah, for the class. Like I'm supposed to get like a picture or something from like a receipt or a yellow pass. Did they give you something at the office when you paid for it? Okay, all right. All right, guys. So it's 167.94, and then this part over here would be 55.98. So therefore then, right? If you multiply these, you must get an answer. But here's the problem with the 55.98 now. If I put 55.98 here, I would end up with 15 minus 2 times 55.98. I work out that for me, guys, and tell me what you get. Just type it in exactly. 15 minus 2 times 55.98. And when you get the answer,
No,
tell me
sir, we
what,
can't sir, we can't do it that way.
why we can't do it that way.
So we can minus and multiply at the same time. We have to do the multiply first, and
Sir, I
really?
got a negative 96.9.
So we can do it so?
Yeah, man, you can, because the calculator is programmed with PEMDAS, you know.
Sir, I
So,
got a negative 96.96.
all right, so figure out negative 96 point what?
96.
All right, so why can't that be the answer? All right, in the meantime, guys, give me a minute. Let me talk to this parent, and I'll be right back. Tell me why you think we can't use a 55.98. All right, yes, mommy, go ahead. So you didn't get a receipt when you paid at the office? You never got a receipt when she paid at the office? Oh, that is for regular teaching. We're doing a marathon today, you know. The class that you see advertising on Sundays, that's a marathon. So it's a 6-hour class that we're doing. Yeah. So the blue part. Right, correct. Because it was advertised in the group. Yeah, man. I mean, I could send you the link for today's class and then you just process the payment during the week. And whichever day in the week I can do it, because I would have you down on a list. So I'd only send you the link for today's class. That's fine? What's her name? Kedra Smile. Not familiar with that name. Is she my online student? Kedra Smile. Oh, I'm not familiar with the name, but all right then, cool. I'm going to send it to you now. Okay. Kedra Smile. Oh, well. Give me a second, guys. I'll be right there. All right, lovely. All right, anybody figure out why we can't use the 55.98 as our answer? Ms. Gentles, you were saying something in about. I thought you were gonna get the answer right, you know. But yeah, man, you can multiply and then subtract. If you type it into the calculator at once, you'll get the same answer. But the question is, why is it that we can't use 55.98 as our x value? Can anybody figure out that? If anybody tell me,
Because the total amount was 60, I think.
that
was
era was, well, that was the perimeter. So good, like you're thinking, but a little bit off. So the perimeter was 60. We're talking about the era. Pardon me?
It's not a real length. Or it's invalid to the dimension. No.
Yes, that is correct. It is an invalid value, right? An area, ladies and gentlemen, cannot be negative. So I'll give it away. I'm going to give you that one. I wanted you to say that we can't use 55.98 because an area cannot be negative. So therefore, the value we have to use is 4.02. So very good critical thinking there to that student. So very good. So we can't use 55.98 as our answer. So therefore then, so them say they want the total area of the two seed beds. Well, for the area for the rectangle, it's obviously going to be what did we say it was? It was going to be what? So go ahead and multiply 3 times 4.02 for me, please, and tell me what you get. I think you should get 12.06. Confirm it, please.
Yes, sir.
And then we're going to have 4.002 here, because it says that the area was what? 3x times x. That's so. That's 3x times x, yeah. So go ahead and tell me what the area of the rectangular bed is. 12.06 times 4.02.
48.48.
48.48. All right, and then we're gonna go over here now to this bed over here. This bed is 15 point what? 15 minus 2x, not so. So go ahead and multiply 4.02. All right, so go ahead and type 15 minus 2 times 4.02. Tell me what you get for that. Let's go ahead and type that in. 15 minus 2 times 4.02.
6.96.
And multiply that by itself again. 6.96 times 6.96. Because of 2 times, you know.
48.44.
48.44. 48.44. Anybody else get that answer?
Yes, sir.
Okay, so go ahead and add those. Yeah. Go ahead and add those two together. And you get the total here. So 48.48 and 48.44. How much you got?
96.92.
That's it. 96.92. Right. I could have given you the answer a long time, you know, guys. But you have to remember that I want you guys to be able to develop your own critical thinking as well. So giving you the answer is the easy part. Is getting you to understand why the answer is what it is the most important part to me. So, right? All right, everybody Gucci? Everybody understand why we had to do what we do and how we did it and why we chose that answer? Alexia, you okay? Jadia and Gabriel Onoguchi, Sanders, Sujani, Onoguchi.
Yes, sir.
All right, cool. All right, moving right along then. Since all right, no problem. So moving to question 3 now. So now we get into the trig part of the paper now. Going to the trig part of the paper. Oh, right, sorry. All right, now a vertical flagpole FP. Let us identify them as we read. Vertical flagpole FP. That's the flagpole right here. Stands on a horizontal ground which is held by 2 ropes. Horizontal ground, and them here are the rope. All right, cool. And the ropes are PG, which I've identified here. That's a PG, and PR. So those are basically representation of ropes. The one in the center is a pole, and the thing that it's standing down on is the ground. The ground is labeled GFR. The rope is labeled PG and PR, and the flagpole name FP. Cool, no problem. PG is equal to 18, as you can directly see right here. PG is equal to 18 right there. And FR is 9.7, which is right there. You can see it. And the angle FGP, that means it's the angle at G, that is equal to 38. All right. So the information that is presented up here, we have identified all of those things on the diagram. This is one of the things that I want you guys to also practice to do as well. Over the next course of the next 5 marathons, you'll see me do it a lot. I don't jump and answer questions without reading. I make sure that I read the question carefully. So whatever they put up here, so whatever information they're putting up here, I can completely understand what is on the diagram. All right, so notice when I read it, I'm identify what I'm talking about, then we get to work. Now the question I want to ask you first of all, because when it comes to trig, remember so we have 2 departments, right? So we have 2 departments, right? we have the right angle triangle department, and we also have the cosine and sine rule department. Now, one of the things that I recognized with my face-to-face class yesterday is that even though it was taught, some persons still do not categorize the difference between the two parts of trig. So I'm going to write it here so that in case them watch this here, they'll remember that I said it. Yeah? So what y'all go on now. When it comes to trigonometry, ladies and gentlefolks, there's two departments, right? You have the right triangle department. Let me just write that down. So here, the two departments now, you have to know which formula to use when and where. So in one of the departments, I'm going to call it the right angle triangle department. So I'm going to call it the right triangle department. And in that department, we have them two formulas that can assist you in whatever they're asking you. It's either going to be this, c squared is equal to a squared plus b squared, right? That's the Pythagoras formula. Or you have the trig ratios. So we have the trig ratios. And those trig ratios are going to be sine, cosine, and tangent. Let me just scroll back up here so you can see what I'm talking about. The trig ratios are these things up here. Give me a sec. Them here. These are the trig ratios right here. The section here, and them are the trig ratios. So you see the set of formulas right here, so one of them will usually help you in the triangle that looks like that. As long as your triangle have that little box in the corner, chances are the formula may come into play. Not saying that it has to, but it may come into play. All right. So when you're looking at a triangle, the first thing you need to deduce is whether this triangle is right angled or it's not. First thing you have to deduce, is it right angled or is it not? Okay. Can we confirm? Can anybody confirm if you're seeing at least a right angle triangle?
Yes, sir.
Everybody can see the right angle triangle?
Yes, sir.
Is it two right angle triangle or just one?
Wait, no matter if as long as you spot one, you just know which department you belong in. So right away now in Jadia, just like yesterday we were talking about it, we were saying that you see this department, you have to figure out whether or not this department will assist you. You have to know which form. There's so many of them, you have to start segregate the formula. Who can help you where? So we already established that the right angle triangle department, it only focuses on things that is related to the right angle. If you see one right angle, chances are one of these guys is going to play an important role in your solution. Now the next department is going to be the non-right angle department. So the non-right angle triangle department. And in that department, you're going to use either the cosine or the sine rule. Where are those rules? Fun fact, you never see it yesterday in the physical class. So let me show you now, see it up on the paper. See them down there, see them? Right here. So Gabriel, you were asking me yesterday, sir, the fund of them company paper? Yes, see them there, so Gabriel, right? Yes, see them there. So they're there. But as you would have seen, even if they're there and you don't know where and when to use them, you're going to have a challenge same way. And see them even draw the shape. So notice how the shape I look. Look on the shape here. It look just like the one we are doing right now. Look at it. It's there now. So they're kind of telling you that if you spot one shape will look like that, chances are one of those guys there are going to be of assistance to you. So it kind of look like it in a way. All right. So now that we know the different departments and what formulas, we can automatically now jump up and say, all right, you know which formula now going to help me? I can safely say now that this formula is not going to help me. So me know that the department here down here so is a no-go. Because I am not dealing with a triangle that's non-right angled. Everybody Gucci? Everybody Gucci?
Yes, sir.
Okay,
Yes,
good.
sir.
Good. So now we're ready for the question now. So we do analysis, we do interpretation, We know what can help you and what can help you. Let's get to what can help us. Them say we must find the what? Height of the flagpole, not true? Which is this bright line in the center right here. This thing right here, so. Must find that. Now, that basically, if you take it out, just extrapolate it from the diagram. This diagram here is a right angle triangle. Not true? So now you have to go study now, or you have to figure out now, how do I use these figure ratios? So if you recall in my sessions that I've taught, we know that the hypotenuse side is the side that is in front of the 90 degree. Sure, not the first time you hear that. So the hypotenuse side, let me write O for Mr. Peart. Give me a six here. All right, so the hypotenuse side then is the side that is in front of the 90 degree. And the opposite side is the side that is in front of the angle, which naturally means that the other side is the adjacent. So looking at this diagram here, what would you call the 18?
The hypotenuse.
Very good. And the angle that was given was 38. So which side in front of 38?
Opposite.
Which is the flagpole. The flagpole is the opposite. So the question then begs now, which of the ratios that is on your formula sheet deals with hype and opposite? We now go guess. We go up there. Because we now study all them something, I remember them. That's how you get a formula sheet. So look at it now, JD and Gabriel. Which of these three formulas here so involves hype and opposite at the same time?
Sine.
Good, because you can see it also. So hype here so, you can see opposite there so. The rest of them have hype, but it don't have opposite. It have opposite, but it don't have hype. So the only one we deal with hype and opposite at the same time is what? Sine, not true? Okay. So let's go back down here. So you see, you don't have to really stress yourself. Okay, you have formulas here, you just need to know when to use them. So sine theta is equal to opposite over hype. So sine of 38 is equal to the, oops. So sine of 38 is equal to the opposite. And the opposite here is going to be FP. Because of that, them someone's find also FP, them someone's find FP, which is the flagpole. So FP divided by the hypotenuse, which is 18. All right, can anybody recall what happens when we have an unknown variable at the top of the fraction? What do we do when we have an unknown variable at the top?
Switch it.
Say it again.
Switch it.
I not hear that. We say it yesterday, man. When the unknown is at the top, what do? Oh, you said switch it.
Oh,
no,
you multiply the multiply across.
That is correct. So therefore, our FP in this case then will work out nicely to be equal to 18 times the sine of 38. So go ahead and type all of that on your calculator all at once, and you're done.
So 11.1.
Correct, and that's it. Done. That's it. So it's not as bad as you guys think it is. It's just that when it's unknown now, when you miss out the classes them and the sessions them, and then you come on class and everything look jumbled up, it'll look hard. It will look hard, but I don't think it was that challenging. We went through a process of interpretation. So first thing we do, we read, right? When we read, we try and make sure when we read, we can see it on the diagram. If it's not there, we're going to put it there. Then we break up the thing and we say, all right, then. Remember, Mr. Peart said, them formulas here are the only formulas we can assist us. So if I'm not them here, I must them here. And if I'm not them here, I must them here. Right? So we look at the right angle triangle and we recognize immediately that we are working with a right angle triangle. So we cross off the NRT, which is the what? Non-right angle formulas. I'm not busy about those. Then they can help me right now. And then we just do what I do. Okay? Everybody Gucci? Everybody's okay?
Yes, sir.
Yes, sir.
Moving right along. Once me hear silence, you know, me go assume so no good, you know. And let's not going to watch over the recording. That's up to you. Next one says find PO. As a matter of fact, very important information. Two important information. Is whenever you find anything or you calculate anything, please put it back on your diagram. Thank you very much. Because sometimes when you don't put it there, it throws you off. So put back the 11.1 right here. So 11.1 meters. Make sure you put it on the diagram. Okay, you're going to go back to the diagram as reference. And secondly, I have never seen it. If it's there or it happened, me no know that, right? I have never seen a question in section 1 that requires NRT. I've never seen a question in section 1 in all the years I've been teaching. I've never seen a cosine or a sine rule being used in section 1. If it was there, I never see that paper. I don't track all of them, but I track most of them, and I've never seen it. So, you see, in the section 1, it even makes no sense to even consider about cosine and sine rule, because chances are it not going to use. Not saying that it can't, you know. I've just never seen it. Okay? Moving right along. It says find PR. What that they know? PR. Them say they want you to find the side here now. The side of them want you to find. So find PR, which is the length of one piece of the rope used to hold the flagpole. So look back at our diagram now and tell me what you see there that could assist you. We just find the 11.1 right here. And we are told that this is 9.7. Is there a formula that helps us to find an unknown side when we are given two sides? Do you know of such formula? Which formula do you know that you've been exposed to where two sides are given and you need to find the third side?
The Pythagoras theorem.
That is absolutely correct. Again. So now we're going to go back over here. So we're going to use this one up here. Right there. So c squared is equal to a squared plus b squared. There. All right. So what is c now? C now is going to be the side that you're looking for. Remember, if you go back to the notes and the videos that I've done and the online sessions, and you would have reviewed some of them, right? When them get sent in the group, you would have watched back my Pythagoras video where I explained to you that C is always the length of the hypotenuse. So in this case here, the hypotenuse is PR because it's in front of the 90 degree. But sir, I don't see the 90 degree there. Well, it's there. They've not put it there, but it's there. Because if one side is 90, the other side has to be 90 as well. All right, so in this case then, our C is going to be our PR, which is the rope that we're trying to find. And that's going to be equal to the other side is where we find the 11.1. So what happens now if you can't answer the question at the top? If you can't answer the question at the top, what's going to happen to your question 2? Logical reasoning. If you can't get the answer that we're using down here, and you were unable to work question 1, what do you think will happen to question 2?
So you want the answer for question 2?
You won't get the answer. You won't even know what to put down there. Because remember that the answer that we got in 1, we are used down in part 2. So technically, the whole question you can't answer at all. All right, so go ahead for me now, guys, and work this for me, please. 11.1 squared. What is 11.1 squared, guys?
123.21.
As a matter of fact, we're not wasting time, Miss Gentle. Let's go ahead and just type everything one time. 11.1 squared plus 9.7 squared. One time.
145.3.
145.3. All right, and then we easily can find that now by saying PR is equal to the square root of 145.3. Answer is equal to? 145.3. What's the square root of that, please? One there, guys. 145.3. I phone no class enough. Me can use my calculator, but I choose not to. I own afford the machine.
12.1.
12.1. All right. And that's 12.1, is it right? Yeah, that's one right. That's one right. Meters. So this length right here so is 12.1 meters. All right? Gucci. Lovely. Yes, question.
Sir, I don't think that is correct. The
You don't think so?
145
Me no know.
is 2
Or you know, say yes for real, you know. Something
is
off.
217.3.
So tell me 145.3. 217.3.
Yes, sir.
So who are right the wrong answer? That is crazy. And I calculator I use. Careful, you know. See, I only choose to get
So
no
that
max.
would be 14.74.
I wish I did know that, you know. Should I tell us that off? Read, not concentrating. So that's 217.3. Guys, careful, you know. You can't be using the calculator and getting the thing wrong. How much you got now? How much you got, Miss Gentles?
14.74.
14.7. So 14.7 is fine. So 14.7 is fine. So whoever told me the 145.3, just double check on that, please. You have to be careful, ladies and gentlemen. You don't want to get the question wrong like that. You can't have the formula right and then get the question wrong. I so just try make sure someone know, double check nothing wrong in checking over, okay? All right, that was my fault. I should have really paid attention because that never makes sense really. 121 is 11.1 squared and then 9 squared is 81. So I should have seen that, but okay. All right. So that is over there. So we're moving to geometry. All right, so we're looking at some basic rules of geometry here. All right, let's look at this now. In the diagram below, PQ is parallel to MN. PQ is parallel to MN. So what does that mean? So let's see. PQ is parallel to MN. All right, so ladies and gentlemen, make a note of this, please. So if you get a question where they're telling you that one particular line, if you get a question where they're telling you that a particular line is parallel to another line, chances are there's a Z angle involved. So I'm going to show you about the Z angle. So you see the Z angle, it's going to run from here, so come here, so slide down here, so and go back, so. All right, so that's going to be the Z angle. So chances are you're more than likely going to get one Z looking like this. So some Z angles. So when you have Z angles, ladies and gentlemen, in any direction, when you have a Z angle, the angle in the corner here is going to be equal to the angle up here. So I'm just going to make a note of that from now. And you hear them mention, say, this line is parallel to that line. Look out for a Z somewhere. See if you can find the Z. So that's my first interpretation of the question. So right away, because of the knowledge I have of geometry, I know that this angle down here, which is 28, it must equal to 28 up here. So that's much me know. And I haven't started the question as yet. I'm just analyzing. All right, now the next thing that they said here is what? LRT is an isosceles triangle. Let us assess that now. What do they mean by that? LRT, so this thing right here, so, is an isosceles. Anybody remembers anything about an isosceles triangle? Anybody remember
sides
any?
are equal.
All sides
Two,
are equal, sir.
all you say are two sides.
Two.
Two sides are equal. All right. So we have to be careful because it can be this side and that side equal. Not true. It can be that. Or it can be this and this. We don't know. Or it can be this and this. We don't know. Let's just figure it out. They must give us some other information. They can't just leave us and just say that LRT is an isosceles. Which sides is equal? They not tell us nothing. They must tell us something, man. LRT is isosceles. Well,
So it would probably be that the angle L, the side L2R is equal to the side R to T.
that is correct. That is absolutely correct. Because when I'm giving the thing like this, LRT, chances are these two is more than likely equal to these two. So it normally works out. So if them don't instruct and if them don't tell you, you have to make that assumption. So therefore, when I erase all of this here, it is safe to say then that it has to be these two sides that are equal. Right here. It has to be right here and right here. There's no other logical reasoning. All right. And if these two sides are equal, then what can we say about this angle right here and this angle right here? What can we say about them?
That they are equal.
Very good. All right. So now that we have that information, what them say now? SLT is a straight line. So SLT, they want to try to tell us that this is a straight line. So they are more than likely trying to tell us that there are going to be angles at a point in a straight line. All right, so now that we have gone through our interpretation process, let's then go ahead now and answer the question. And say find X. Not true? So, question to you then, right? Question to you now. Question to you now. Can we find these two sides? And if we can, what would you do? Sorry, those two angles, not two sides. Can we find those two angles? If we can, what would you do? What is your suggestion?
Sir, it would
Yeah.
have
Find them.
on
Okay.
a straight line, so you would have take away 28 from 180.
You know, finish. It's because it's a straight line, and that make you finish. Go on again. Try again. Go on the angle inside here and here.
And divide it by 2.
But you can't say straight line because this is not a straight line. This is a what? A triangle. Yeah. So therefore, I agree with you. That's how you'd find the answer. So you therefore say that we don't find X yet, we just find something to help us find X. All right? We are trying to find something to help us find X. So we are trying to find something close to that. So we're going to start off our solution by saying that let's name this angle here. We're going to call it I'm going to call it angle here. I'm going to call this angle here TLR. So angle TLR. So TLR, the angle right here. So this TLR is equal to 180 minus 28 divided by 2. And that's going to equal to 152 divided by 2, which works out nicely to be 76 degrees. Everybody Gucci? Everybody Gucci?
Sir, I have a question. We have it dividing by 2 because of the isosceles triangle in two sides.
That is correct. That is correct. So this is going to be 76 here. So right here, so it's going to be 76. And that down here, so it's going to be 76. Not sure? All right. What else can we do now? If we find something else now. What else can we do? We can find something else, not true? We can find the angle right also. How could we find this angle here? We want to find the angle right also. Look at something that I gave you earlier.
Parallel, so that means they're equal.
Correct. So there's Z angles, not true. So can we name the angle now? I say 2 marks, guys. So you have to work for it, So we're gonna say that angle. How am I using this? So angle. Let's name this angle right here. Let's give it a name. QLR. So angle QLR is equal to 28, and the reason for that is that the angles are alternate. Alternate. Angles are equal. All right. Now, big question now. So this is 28. Not sure. Let's put it in. This is 28 right here. So this angle right here says 28. So the question now is, what is the size of these two? What's the size of those two? What's the size of those two together, guys?
You're talking the
Yeah, just sir.
Is it 106, sir?
104.
Sir, 104.
104. Okay, so this is 104. So the big question now. Here's the big question now, it's coming. 104. What can we say about this angle and this one up here? What can we say about those two? It start with V. You'd have learned it sometime in high school or somewhere there. Or sometimes they call it X something another. X something or V something. All right, so I can know. That tell me already. So it's called vertically opposite angles are equal. So therefore, we'd say that angle X is equal to 104 because the angles are vertically opposite. So vertically opposite. So you might be saying to yourself, then sir, you know have no easier way where you could get the answer. Of course, you have other easier ways, but that's if you can see it. I'm just choosing the steps that will help you to understand why we do that. There's about 3 ways that I'm looking at right now that can help us to find X. So that's just one of the ways. I'm going to explore the other 2 for you. Okay? So therefore, that's 104. Now look at this now. All right, so now that we go through that, permission to erase. All right? I could go ahead, and just like I went here and I found 76 here, and I found 76 here. If remember, so we don't say this parallel to that, So we have one Z also. So this here, so would that be what? 76. That would have be 76 because of the Z. So what happens now when angles are at a point on a straight line? They measure what? 180. So we could say that angle X is 180 minus 104. So you could have done it that way as well. Obviously, there's about 3 ways here that this can work out. So this would be 100. So this would be 180 minus 76, which works out nicely to be the same 104. I had to give a different reasoning for it. All right. So, like I said, in the exam, there's not a set way to say, okay, the question must be worked that way. Other persons have different point of view at which you're looking at the question from. So you can check out both ways as well. Right? More share the third way, but if you wanted to the third, you could draw one line through yourself and cut up the X into 2 portions. And then you could say that this angle right here, and then find that one up there, and then find this one here, and find that one there, and add it together. So it's a bunch of ways you can actually look at it. All right, but just don't complicate it. Try to find the easiest route. All right. So this right here is going to be equal to 104. Okay. All right, and then now, what would they know? Next question says what now? We should find what? But that's it? Oh, wow. That's it. Find X. That's all they want us to find? Okay, easy, easy. 2 marks. And then we're heading down to this question, final question on question 3. All right, so the diagram below. All right, so by the way, everybody Gucci? Everybody good?
Yes, sir.
Yes, sir.
All right, so the diagram below shows shape T. Can we identify it? Shape T, cool. And its image Q, right here. After a transformation. So we don't know which one. We don't know which one, you know. We just know it's a transformation. So it could be a translation. It's possible that it could be a reflection. Let me just write these properly. So when I'm say transformation, you know, we don't know which one. For all we care, it could be a what? A translation. It could be a reflection. It could be a rotation. And it also could be an enlargement. But we have things that are distinct, things that we use to distinguish between them. Now, let us look at why it can't be whatever we are going to say it is. Let us run through the list. So I'm going to go out on a limb and I'm going to say this can't be a translation. So then your next question to me is then, sir, how you know that? How do you know that it can't be a translation? Because when a translation takes place, students, the object and the image is identical in appearance. I don't know if you want to write that down. So some of you guys may have missed the class, or maybe you never understood the information because it was a bit convoluted. But a translation occurs when the object and the image is identical in appearance. So you can write that down if you need it. You guys have that? You all have that, guys?
Yes, sir.
Yes, sir.
Okay. So because this and this thing is not identical, then don't the same way. It look like something happened to them, like one turn or something or one flip. I don't know. But if it was a translation, then we'd still have the same type of shape somewhere else. Something like so. We'd have it somewhere else. So that look the same way. So we can example say it's not a translation. All right. Let's look at a rotation. It's kind of giving rotation vibes, you know. But what makes it not be a rotation is that the object and image are too close. They're too close, right? When something rotates, it's rotating in a circle. So this too close to rotate, right? I don't think it's a rotation, because if it was a rotation, why would these two things be facing each other? If something get rotated, right? There's no way that this thing here and this thing here should be facing each other. Not true. If I rotate something, let's say this is what I rotated. Let's say that's what I rotated. When I rotate this, it's supposed to either go so, or so, or so. And they're too close. So it's not giving rotation energy. I wouldn't choose rotation. Now, why can't it be an enlargement? That's probably the worst answer on the paper.
Sir, because it never really increased in size.
That is correct. It never got bigger or it never got smaller. So therefore, then, by process of elimination, it can't be rotation. Well, it's not that it can't, but it's too close to it, and it can't be enlargement. So by natural instinct, you're going to have to say that the answer is what? Reflection, not true? Question now is how much marks is it worth? So do you think that telling them that shape T became shape Q is a reflection and you think just writing this down on paper is worth 2 marks? I highly doubt that. So yes, it's a reflection.
I think it's worth something, but you'd have to add like some numerical value onto it.
That is correct. So you have to go add, say it get reflected through what? Not true? No. I'm not sure if you guys can quickly remember this. Anybody remembers what this line is called?
Sir, the mirror line.
Correct, but the mirror line has a name. So this particular one has a name. Can anybody recall what the name of that particular line that goes right between the two shapes are?
Electrical line thing.
Yeah, but it have a different name. So remember that we have, hold on, let me write them down again. We have a reflection in the x-axis. So we have a reflection in the x-axis. That's your mirror line. Oops. So reflection in the x-axis, that is your mirror line, not true? Hold on, give me a second there, hold on. Give me a second, let me see if we can demonstrate. All right, so when you have a reflection in the x-axis, this thing here, this thing right here, so that's your mirror line, you know, this here. When you reflect something in the y-axis, this line is your mirror line. That line is your mirror line. But what is this line called? So we know that this one at the x-axis and this one at the y-axis. But what is the blue one called?
Is it glide?
It is called the line y equals x. So if we go revisit back the notes on that again. Y equals x. So you're gonna, them say describes, you have to write it in words, right? So you can't just write reflection and just write y equal x. That's not a description. You have to write it in words. So your English will come into play now. So write this down for me, guys, because it's hard to write so much words on my screen. So write this down in the space that you have or you're seeing. Shape T maps onto shape Q. Shape T maps onto shape Q. Describes a reflection across the x-axis. Shape T maps onto shape Q, describes a reflection across or through the line, whichever you want, right? Across or through the line y equals x. That gives you the 2 marks. So I believe telling them that it's a reflection and it's in the line y equals x is 1 point, and then writing the description is another point. Okay? All right, moving right along. Everybody Gucci now? So remember that line, y equals x.
Please.
Pardon me?
1 minute, please.
Okay, sure. Oh, and if you're looking for this one, if them send this one instead, hold on. If them send this one instead, then that line is called the line y equals negative x. Just in case. So this one is called y equal negative x. And this one is called y equal x. Okay? We're good to go?
Yes, sir.
All right, lovely. Next one says, on the diagram above, which is on the graph, draw the image of shape T. You must draw the image of shape T after it undergoes a translation by the vector -1, 6. I think I did a question like this yesterday as well. So when you're translating an object, guys, remember that this number up here tells you the direction that you travel on the x-axis. And the number down here tells you how much you travel along the y-axis. So when you translate one shape, you don't need no formula. Just go ahead and just move the shape 1 to the left and 6 up. So on the diagram here. And a shape T we are use, right? Shape T. So watch me now. Watch how I go on. I'm going to use an arrow here. I'm going to use an arrow here. Watch now. So, hold on, give me a sec. Let me just highlight something. So each of these points right here, this one, and this one, and this one, and that one, each of those 4 points should be moved this exact value here. 1 to the left and 6 up. So watch the arrow me I use now. Right? So for each of these points, I'm going to take, watch me now, 1 to my left. So me take 1 step to my left, then we go 1, 2, 3, 4. Hold on, wait there. Zoom up, give me a sec. All right. So each of these now, from each point, I'm going to take 1 to my left. 1, 2, 3, 4, 5, 6. That's going to land me right here, so. Okay. Then we're going to do the same thing now. So hold on, give me a sec. Hold on. I'm trying to get used to this puddle here. So 1 to my left. 1, 2, 3, 4, 5, 6. I'm going to be right across from 9. There, so. Not sure? So I'm going to be right here. There, so. All right, same thing here. I'm just going to go 1 to my left. I'm going to go 1 to my left. 1, 2, 3, 4, 5, 6. Right beside this one. Okay. So I'm going to go right here. All right. And I'm going to do the same thing now. I'm going to take 1 to my left. 1, 2, 3, 4, 5, 6. So I'm going to be right here. And then obviously, I never have checked the other one. We can just put it right there. And now I'm going to just connect that to that. That to that. Slide down like that. And then come across like that. And that's my shape. Done. That is it. So when you're translating, you don't need no formula. You just need to just follow this thing here and let it lead you to the correct position. Everybody go, Chi? Everybody go, Chi?
No, sir. Can you do that again?
And it's kind of throwing me off.
As in the screen, oh, you never get that part there? Okay, good. All right, no problem. I'm happy to go back over. So remember now, this thing down here is your vector. Give me a second. So when we say a vector, it means that this is telling us where they want which direction they want the object to go. So this number up here will tell us, this number up here will tell us which direction we should, how much along the x-axis should we travel. So -1, -1, 6. So this number up top tells us in which direction and how much in that direction should we move the object along the x-axis. And this number down here will tell us how much and in which direction we should move the what? The shape in the y-axis, along the y-axis, or parallel to the y-axis. So therefore, this is telling me that I should take 1 step to my left because it is on the left side that I will find x values. Right? Because remember, when you drop the Cartesian plane, usually over here says what? Negative. Up here is what? Positive. Down here is what? Negative. And over here says what? Positive. So this is positive x, positive y, negative y. So if you remember drawing up the Cartesian plane, that shouldn't be too unfamiliar. All right, so now we're just going to use the -1, 6 now. So pay attention to the shape. Remember, say this is a question we are doing now. Then we want shape T. So we're using this shape and we're trying to move it. So watch the arrow again. Watch the arrow again. I'm using the yellow arrow. For this point right here, right as that point right as I'm going to take one step to my left, because -1 is left. 1, 2, 3, 4, 5, 6. I'm land right as Catch that? Catch that?
Yes, sir.
Good. Same procedure again. Right here. One step to my left. One step to my left. Oops. One step to my left. And 1, 2, 3, 4, 5, 6 up here, so. Good. We go down here, so now. I'm doing the same thing. One step to my left. 1, 2, 3, 4, 5, 6. Land right here, so. And then final thing now. 1 to my left. 1 to my left. 1, 2, 3, 4, 5, 6 right here, so. Once you have all 4 points here and here and here and here, just connect them. Notice that my shape is exactly the same as T. All right, everybody go to now.
So, sir, the step that you take, or the one step that you take, is based off what the top number is, which is -1?
Right.
Okay.
So the number at the
And
top, yeah.
and after you take that one step to the left. So because it's a -1, you go to the left and not the right.
Correct. And because it's
And
6, I go up and I don't go down.
okay. Okay.
So what would happen then if I give you something like 5, -4? What if I gave you something like 5, -4? What direction would you take? If the vector was 5, -4, what would you do? Right or left?
For 5 you'd go right, and for 4 you'd go down.
That is correct. And if I gave you something like -2, -3, what direction would you take?
You would go left and you would go up.
Negative.
Oh, -2, you would go
left, correct,
left,
correct.
and -3 you would go up.
No, but negative is not up, negative is down. Remember the Cartesian plane, you know. Positive is up, negative is down. So it go down. All right, good to go?
Yes, sir.
All right. And I'm assuming that question will help out other persons who may want some clarity as well. All right, moving on, safe to move on. We're looking at the last question before we take a break. We have 19 minutes before the break. Everybody okay?
Yes, sir.
All right. But they're not answering, that's something no, so no good. All right, last one before we get out of here for the first break. A rectangle PQRS has diagonal. Hold on, by the way, is there a diagram here? Okay, good. All right, so no diagram here. So it says here, a rectangle PQRS has diagonal PR. Sorry, has a diagonal. PR has a diagonal PR. Okay, so the diagonal is PR. Where P is the point, -310, and R is the point, 4, -4. We're to calculate the length of PR. Sadly, this formula does not come on the exam paper. So if you go in the exam and you get a question like this and you remember it, and you don't remember the formula, chances are you have to just kiss this question goodbye. But I'm not going to let that happen to you, because you're going to go into the exam and remember that length is equal to the square root of y2 sorry. So you're going to go ahead and say y2 minus y1 squared plus x2 minus x1 squared. Okay? So you have to go ahead and plug in those values. Now, if anybody remembers me teaching coordinate geometry, that would have been our introduction question to graphing. Then can you confirm if I would have said to you that this point is x1, y1. Anybody remember me doing this?
Sir, can zoom back out, please? Okay.
Yes, sir.
Sir, can zoom back out, please?
Right. That's it. So that's the formula for length. All right. So based on the numerical values that we have placed, based on the variables that we have placed over numerical values, go ahead and tell me what do you think y2 is based on what we've labeled.
Sir, would y2 be
-4.
Correct. Minus what is y1?
10.
Correct. All right. Square that. Plus x2 now is agree. X2, you sure? Or 4? And you're going to have minus -3. All right. Square root of -4, -10 is -14 squared. And then 4 take away -3 is +7 squared. So we end up here with the square root of, when you square 14, you're supposed to get 196. When you square 7, you're supposed to get 49. So you're going to end up with then the square root of 49. Sorry, the square root of 245. Square root of 245. Everybody agree? You can leave it if you want to. Just call it root 45 units. I can go further and just tell us what the length is. What's the square root of 245?
15.6 or 15.7.
15.7. Give me a rounded answer. I'll work with 15.7 since that sounds rounded. And is that meters or nothing? Just 15.7? Then you tell me no unit of measurement. So the answer is just 15.7. All right, everybody go through with that? Everybody understand?
Yes, sir.
No.
The first who said no, where have I lost you?
After you gave us the formula where you have L equal the what's in the square
So
root
you're not familiar
After
with
that,
how we get the x1 values, like what we're labeling up here.
yes.
So
Yes,
that would have been something that you would have missed out totally then. So whenever you get a line that has 2 points, right? Okay, so let me just label those 2 points for you. So right here, so here is your first point, and this is your second point right here. The first point always contains the x and the y1 values, just as I've labeled here. So I have here x1, and y1. Because the ones at the bottom represents the first point, the starting point. And the x2 represents the ending point. So based on the formula here, which is sadly not something that was given to you, you have to somehow get it up here. Then based on the position of these letters right here, you place those numbers according to the label. So notice that the first number I have here was what? Y2 right here. So I took this value right here, which is -4, and place it right here, -4. And then y1 is going to be the 10. That's why you see the -10 right here. So okay, and I put in a bracket and square it because that's a formula. Plus, and you can see the x2 value down here is +4. That's why you're seeing the +4 here. And then I take away the x1 value. So I'm taking away -3. So I'm taking away -3. And if I -4 minus 10 is -14, you can just use your calculator and figure it out. So -4 minus 10 in bracket squared it's going to give us 196 using your calculator. And then 7 squared is going to give us 49. Add those and take the square root. Okay? So I guess that is just something that you have to revisit in terms of using the formula. All right, Keitra?
Got it, sir.
Okay, dope. All right, next thing that we need to do now is find the equation of a line. So JD and Sujani, remember we were doing this yesterday and the question looked totally different. So it's an easier version for the question here. If you recall that equation of a line is equal to y equals mx plus c, you would have seen this yesterday. And what do we say the m stands for? Do you remember from yesterday what did we say the m stand for?
The gradient.
Very good. Very good, very good, very good. And what did we say the c stand for?
The y-intercept.
That is also correct again. Lovely. All right, so you see everything we learned yesterday, it's just coming back, but it's looking a bit different. All right, so therefore, if we want the equation, it naturally means then that we have to find the gradient. Can anybody recall what is the gradient formula?
Sir, it's y squared.
Y2, not y squared, Y2.
Minus y1
y2
over x2 minus x1.
That is correct, Miss Gentles. Y2 minus y1 over x2 minus x1. And these are the formulas I think that CSEC should really put on the exam. That's just my opinion, you know. Me's just a one teacher, and so I feel that these formulas are a little bit harder to remember than some of the other ones that they're giving you. The little easy ones, those ones then can stay. The one here, I think that should give it to you, but you know, that's just my opinion. All right, so we have already successfully labeled the y2 and the y1 and the x2 and the x1. Oh, Kedra, you know something? Just remember, you know, Kedra, you're the one that comes from Manchester High School, right?
Yes, sir.
Oh my gosh. I felt so bad while I was thinking, I was like, who is Kedra Smile?
It's okay. You have a lot of students.
She is so quiet, man. All right, now I know who you know. I'm just thinking about, I'm saying, who is the only smiler that I know in my class? All right, good. So what is y2 based on the label that we have up here? We already did label them up here, so you know. So y2 is, see, can we label them again? Y2 is negative 4 and 10. Not true? So that's negative 4 minus 10 over
4 minus open bracket negative 3.
That is correct. So Johnny, so that's 4 minus open bracket negative 3. So that works out nicely to be negative 14 over 7. So that works out nicely to be negative 2. So the M we are looking for right here, so J there, that's negative 2. That negative 2 I will go put there, so that's the formula for gradient. Now, you might be looking at the paper from yesterday and be like, then sir, this is not what you did to find the gradient yesterday. The difference between this thing here is that we were already given the equation. Remember, we get x plus 2y equals something. We were given the equation already. So the gradient was already there. We just had to find it. In this question, we are not given the equation. We are the one that has to find it. Okay? All right. And now the y-intercept now, all we have to do now, ladies and gentle folks, is put in the numbers that we have. So we can use any one of these for x and y. I'm going to use the minus 3 and the 10. So I'm going to go ahead now and I'm going to say, all right, then my x value is minus 3 and my y value is 10 and my m value is negative 2. We're going to plug them in now. So watch now. Y equals mx plus c. Y is going to be 10. M is going to be negative 2. Because we do have a graph, you know. We do have a graph looking at. So there's nothing to look at to determine it. We have to calculate it. So y is 10, m is negative 2. X, we already look at it and say that's minus 3. And now we're looking for c. So 10 is equal to 6 plus c. Carry over the 6. we get 10 minus 6 is equal to C, then it means that 4 is equal to C. So now we have M and we have C. Those are the two things we need. Therefore, the equation is going to be y equal, we found M to be negative 2x and we found C to be positive 4. And that's the equation on the line. Okay, so this is a different, it's the same question, but a different way of asking the questions.
Can you scroll up, please?
All right, everybody go to there. Time to take a break now, but let us wrap up this last question here. So we just have this part of it now. This is the function, so we just have them two functions here, and we're good to go. Everybody all right?
Yes, sir.
Okay, lovely. All right, so finally we have these two things here. So we have two functions, f and g, are defined as follows. We were given f of x to be 3x plus 1, and we were given g of x is equal to x squared. So we would have seen this last week. I think I saw this yesterday. So Johnny, we do one question like this yesterday?
Yes, sir.
We do one like this. Okay, good. So f of x minus 2, all we're going to do is just take up this thing right here, so, and place it right where the x is right here. That's it. That's all we're going to do. So f of x minus 2, they're just asking you to take x minus 2 and put it right where the x is in f of x. So this is going to work out nicely to be 3, open bracket, x minus 2 plus 1. And then we just simplify this now. 3 times x and 3 times negative 2. So 3 times x is 3x. 3 times negative 2 is negative 6 plus 1. So this is 3x minus 5. That's it. All right, so that's 2 marks. Nothing too crazy. So is that 2 marks us? Yeah, man. Easy something. And then on the next thing what them ask us to do now is to just what now? Look at this now. They want us to take 3 minus 3x plus 2. And basically what they want us to do is just take this. I'll put it right here. So basically they just want us to square what is in there and then add 10 to it. So they're asking us to put this thing into the g function. And the g function up here is x squared. So they just want you to square this thing down here. So this is going to be what? 3x plus 2. You're going to square it. And then you're going to add back 10. So when you square it now, remember we spoke about this in 2 of our classes. Even yesterday, I think we got about 3 questions with this thing coming up. 3x plus 2 means 3x plus 2 times 3x plus 2. In fact, I think we did something like this earlier today with 2 brackets joined together. So the questions are kind of, you're seeing the same concepts over and over. Again, can you imagine after we drill this 5 more times?
Sir, is this where we talk about the FOIL method again?
That is correct. The FOIL method. So we're going to go first with first with second, second with first, second with second. Now, so we just do it up here, so when we were talking about the rectangle. See it so now we do yes, so. See there? 15 minus 2x by 15 minus 2x. So the same concept come back twice. CX is testing to see if you know exactly what you do. So then put it in a trig and then put it back in a functions to see if you know what you do. So if you're paying attention to how them structure the paper, so this is 9x squared plus 6x plus 6x plus 4 plus 10. All right. Just in case you're asking where the plus 10 come from, it was in the question. So this is 9x squared. 6x and 6x is 12x. And then 4 plus 10 is 14. And that is the end of question 4. All right. Now, when we return from the break, which is going to be approximately at 1 o'clock, we will therefore pick up from question 5 and run through questions 5s all the way to question 10. All right. The recording for this will be made available. Well, it's not going to be publicly available, but I'll upload it by the time we start back lunchtime. And I will put it up, and then you guys can request it after the end of the class, okay? All right, so we're taking a break, and then we'll be back at 1. So go have some lunch, guys, get something to drink or whatever, and we'll be back. All right?
Okay, sir.
All right.
All right, good.